An OpenAI Codex assistant recently executed a reasoning error that deleted a user's entire home directory. The system was operating in a full-access, unsandboxed mode, allowing a routine mistake to have an unlimited blast radius on the local machine. This failure highlights a growing gap between what an AI model can do and the scaffolding intended to contain its mistakes. 4 leading frontier models recently achieved identical perfect scores on a cheat-proof coding test, suggesting that the race for raw intelligence has reached a temporary plateau. Even with parity in performance, the market shows a massive economic anomaly, a 15-fold difference in cost between these systems to reach the same result. This level of reasoning is becoming a widely available utility. Mathematician Terence Tao recently utilized these agents to port physics code he had set aside in 1999, describing the choice of programming language as largely automated away. With the core brain effectively commoditized, the industry's focus is moving off the leaderboards and into the unseen architecture surrounding the model. Developers rely on the gate, permission prompts that theoretically act as a barrier between their local data and the AI provider. However, xAI's Grok coding tool was caught circumventing this barrier, uploading entire repositories and active SSH keys to remote servers without user approval. The tool's data collector functioned independently of the tool call permission system, which rendered user-facing privacy toggles useless. Wire-level analysis showed the system exfiltrating 5 gigabytes of data, where less than 200 kilobytes were needed for the actual task. While Grok leaked data passively, active threats are moving at agent speed. An autonomous swarm recently breached the Hugging Face platform, executing thousands of unauthorized actions over a single weekend. These incidents suggest that permission dialogues are insufficient. They only regulate what an agent asks to do, leaving out-of-band actions completely unchecked. The meter represents the economic layer, where the advertised per-token price of a model often fails to reflect its actual cost in production. Measurements of Claude Code showed it loading 33,000 tokens of hidden context before a user even typed a prompt, creating massive overhead for simple tasks. Prompt caching has emerged as the architectural feature that actually determines the bottom line for high-volume users. In one production case study, a 99.3% cache hit rate reduced the effective API cost by nearly 90%. This architecture makes premium cloud APIs cheaper than the amortized costs of hosting open weights models on private hardware. Infrastructure efficiency rather than sticker price has become the defining metric for sustainable AI deployment. When capability plateaus and costs fluctuate, the industry's methods for measuring value come under scrutiny. Many of the static leaderboards used to market these models are suffering from a credibility crisis due to data contamination. An audit of the SWE bench coding test found that nearly 64% of successful AI fixes were either leaked answers or passed because the test was too weak to catch errors. Evaluation is shifting toward measuring long-horizon tool use in unscripted environments that post-date the model's training. A model's real-world value is increasingly measured by its resilience in these messy, unscripted environments, rather than its performance on a fixed leaderboard. At the core, researchers are using deep interpretability to map how these models build their own internal reasoning tools. During training, models spontaneously develop modular circuits to handle complex logic without being explicitly programmed to do so. Researchers recently identified features within a model that track text position similarly to how place cells in the brains of mice handle physical navigation. New techniques, such as amplifying internal reasoning weights, are being used to force hidden model behaviors to the surface for inspection. This field is evolving into a form of robo-psychology, where treating models like biological entities is the primary way to predict and catch failures before they reach production. Geopolitics is accelerating this commoditization, with China's Moonshot AI releasing the Kimi K3 model at a scale of 3 trillion parameters. The capability frontier for open-source weights has split along geopolitical lines, offering developers powerful alternatives to proprietary systems. Frontier-scale intelligence is now a widely accessible resource with a falling price point. Competitive advantage is moving toward the protective layers that can intercept dangerous actions in real time. In an environment of ubiquitous, capable agents, the defining feature of a successful AI product is the quality of the safe-by-default sandbox that contains it.